So I am running a two-way ANOVA here. Actually, it's an ANCOVA because I'm controlling for another variable using SPSS. This is an assignment I had for my class. I said using the ANOVA dataset, which I downloaded already, you are to run a two-way ANOVA exploring the effects. And these are the variable names that I had, and they're named as they are for reasons that I like. Gender, which I call female, W1 means this is the first time point wave in a study that had many waves. And white race, so it's just my race variable, so that's white versus non-white. On physical activity support, that's like support from family and friends for being active. Controlling for physical activity enjoyment, that's using this PACES measure. And that should be wave 1, not wave 10. It's a typo. You are to test all two-way interactions. Your research question is one, does gender affect physical activity support after controlling for the effects of physical activity enjoyment? That's a good question. And is the effect of gender, if any, moderated by race? So white versus non-white. All right, and I had the students as usual, just in prepping for learning how to publish at some point, completing your prototypical descriptive statistics table, which you can use this because this is the prototype that you want to use when you're publishing, and for most journals. And then this would be another table. This is a table with the results of the model we're running. Provide a plot of physical activity support with gender on the horizontal axis and different lines for race. Let's so we can test for an interaction and then also visualize it. Interactions are easier to interpret when they're visualized or when they're plotted. Interpret the results, focusing on the interactions, and provide effect sizes. So I'm just going to show you how to do this on SPSS. That's my goal here. The write-up isn't the aim of this project. So here I am. I downloaded the data set. As you know, with SPSS, you have two options. You can look at it through the variable view or the data view. And now there's this other overview, which is kind of cool, but I don't really need that. So I like the data view and the variable view. Okay, these are all my variable names. So I gave the students the variable names. When I run these analyses, it's often easier to run them with the variable names. And you'll see what I mean when we're using the dropdown. I don't generally use the dropdown when I'm doing a professional project. But when I'm teaching, I do a mix of dropdown and syntax to teach my students. So here's the dropdown. And to run this is my parrot in the background, Piper. He's talking. So when I'm running this analysis, see, with ANOVA, we're generally comparing means. And when you use the compare means option here, you'll find that you have some ability to do things, but really you can only do a one-way ANOVA. And when we're looking at, so a one-way ANOVA means there's one independent variable. Your outcome is continuous, right? So there's one independent variable, like say we're comparing males to females, right? But when we have two independent variables, like in our case, because we have males, we have sex and we have race variable, right? Plus we have a control variable. We can't use this. So we go to what's called a general linear model, a GLM. There are two of them, two GLMs, right? There's generalized and general. Generalized is more robust in that it can accommodate different distributions. General linear model assumes more, a normal distribution of your dependent variable. Here you can use something like general estimating equations where you can, hey, this is what I believe the link function is, function linking my independent and dependent variables. So there's a lot more options there. And then, of course, dealing with categorical outcomes. But here we have one dependent variable. So this is a univariate analysis. If we had more than one dependent variable, that would be a multivariate analysis. The dependent variable is your outcome variable. If we have repeated measures of our dependent variable, time one, time two, time three, we'd use this. Okay. So we're going to use a univariate analysis here of the GLM. So in our case here, we have our dependent variable has to be continuous. In SPSS, a continuous, some people call it quantitative variable, some people say interval ratio, has this little ruler by it. Now see how it has all the labels here? Sometimes it's hard when you're using the drop-down tab, it's hard to find the variable name. I mean, it's given when you scroll over it, right? See how it's in the corner there, but it's kind of difficult. So instead, I'll right click in here, and this is again not using Apple and an Apple computer because I'm not I don't use one, so I can't tell you how to do this same thing, but it is possible to do it there too. If I right click, I can click as I did, I can look for variable names being displayed in here. So I know what my variable names are because I told my students what they'd be. So I'm going to take this variable and put it under dependent variable. Okay, so that's my dependent variable. And I have this option of fixed and random effects. Most of the stuff that we do involve fixed effects. And in research, we generally do that where we assume the effect of a predictor on an outcome is the same for everybody. If we have random effects, we can say, well, no, we don't believe that's the case, right? The effects differ depending on some grouping, could be by family unit or something like that. So this, or by classroom or something like that in a school or schools, whatever. But here we're going to assume that they're all fixed. And these are our two predictors, female and white race. So that's the name. And I tend to name my variables based on what the level one is. When I have a binary variable, I like to code them 0 and 1, and you should do that all the time too. Makes it more simple to interpret. So female is 1, white race is 1 here. Okay. I don't have any random effects or random factors, but I do have a covariate. I said we're going to be controlling for physical activity enjoyment, and that's paces. So a covariate in an ANCOVA, what it does is it removes the proportion of the variance in the outcome that is attributable to this variable. So it kind of cleans up that variable because that's what you want to do. In theory, it's not supposed to be related to the two independent variables or the independent variables, but it can be. And if it is, just analyze it and explain. That's all. But it shouldn't be related. All right, so that's the first step. So I got my model set up here. Let's go to the model command here. So there's nothing in here now, but you see there's possibility of something being there. So we're going to build terms ourselves. Okay. Obviously, this is default anyway, but I'll do it anyway. We obviously want what are known as the main effect. So the main effect is just the effect of each of these predictors on the outcome. We want the main effects in there. I also told my students I want all two-way interactions. So I'm going to highlight these again. Oops. So if I hit Shift key, there you go. That'll highlight all of them and put them in here and see it creates all the possible interactions. Okay. So now I have my model with all the main effects and all the interactions. Okay, let's see, and hit continue. All right, I don't need to worry about contrast because I don't have any variables that have more than, two levels here. Hit plots, and I said I wanted, let me go back to what I said I wanted specifically. Plot. Didn't I say plots? Yes. Provide a plot of physical activity support with gender on the horizontal axis and different lines for the different races. So I got gender on the horizontal axis and separate lines for race. So this is going to create a nice little graph for me. And I hit add to make sure I add it in there. Everything else is fine. Line chart, fine. I don't want a bar chart. Continue. I don't really care about anything else at this point. Let me see if there's anything else I want. You should get you definitely should get parameter estimates. Right. So, I mean, you're not going to, when you're presenting the results of an analysis, you want to make sure you have the parameters when you're creating your table. Generally, you'll make a table. Like in fact, I asked the students to make a table. The B values and stuff like that will go in there. And let's see, estimates of effect size. They did ask them for that. And there's a lot of other stuff you can put in here too, like residual plots, homogeneity tests. Like there's a lot of things that you want to assume too, like homogeneity of variances, et cetera, across the different levels of the predictors. Just different stuff, but I'm going to leave it at this for right now. Okay, you can actually ask for observed power too. A lot of different things. We're going to leave it at this for now. All right, and I'm not going to do the mean. So let's just take a look at this. There you go. Here's our output. So this is showing us what we have here. We have 705 males, 716 females, and with a race variable, this is what we have. Distribution, right? That's our distribution. Here we have this nice little ANOVA table. Lots of effects here. I'm not as interested in the ANOVA table. I'm more interested in the parameter estimates. Generally, that's what we're interested in, is the parameter estimates. We also always focus on the interactions first, and if the interactions are not significant, we look at the main effects. So we look for interactions. So we have a race by physical activity, enjoyment, interaction. So this is saying that race is moderating the effect of physical activity, enjoyment on physical activity support. So we have that right there. Okay. What else do we have here? And we do have a race by sex effect. So, and now one thing that it's doing here, you'll notice that it says female equals 0 times. So interaction is just a product term, but what it's giving me is the 0 by 0. So this is where female is 0, that means it's a male. And where white race is 0, that means it's a non-white individual. So that's giving me the effect for that grouping. I can alter that if I want, but I'm going to leave it at this and we'll just interpret. Okay, and so let's go to the figure. Oh, by the way, if I'm writing this up, all these 0 ones, or these are for the ones that are the contrast. So it's being contrasted to this, right? Right. So I don't need these lines in my table. And the beauty of SPSS now is that it's done in a really nice way where we can actually just copy and paste this into, the way I do it is I copy and paste it into an Excel document and then beautify it, because you don't want anything like this in your output. You want to make it look nice, and I can do that. I also get my partial eta squared, which is my effect size, and I gave heuristics for what's considered small, medium, and large in the assignment. Yeah, here, partial eta square, small, medium, and large. So you can interpret those again. So let's go back and just look at these output here. So I'm not as interested in interpreting. I mean, first of all, I had mentioned that the physical activity enjoyment shouldn't have an effect on, shouldn't be in any way related to my independent variable, but it is in this case with white race. So that's why we have to interpret that. We would interpret that effect, right? So, it seems like it's more effective for people who are white than non-white, because this is a 0 here, right? So that means this is non-white and there's a negative effect. It has a negative effect on physical activity support, apparently if one is non-white in this case. And then here we're going to interpret this one because that's one I drew. Okay. All right, so let's take a look at this really nice chart here. So we have our race variable. We said we want a separate line. So we see this is the non-white and this is the white. And then we have male and female, and we're looking at physical activity support here. And this is already controlling for physical activity enjoyment. So we see that males have much more support than females do among non-whites, but they also have more support among whites, but the effect is more dramatic among non-white than white. That's why we see an interaction, and a telltale sign of an interaction is when lines cross like that. Okay, so that is an example of how to run a GLM or a two-way ANOVA with a ANCOVA in this case. By the way, if you are interested in syntax, and I would strongly encourage you to do this, if you're interested in syntax, you double click the syntax. First of all, you have to have the syntax printed, and that is something you can do. I believe it's under, oh, again, it's Let me go to the, actually, let me go to the, here. I believe it's under this. Let's see now, data, edit. Edit under options. Yeah, here under viewer, and it says display command lines. You should do that because then you get the syntax. And I'll tell you what, if you're planning on getting a job somewhere after college or at whatever, where you use SPSS or any computer package, you're going to be writing syntax, and syntax is so much better. So what I do is I just, you know, like I said, I double clicked here. I'll go ahead and copy this, then open a syntax file. New new syntax and paste it in here, right? So what this does is it gives me syntax for how to run something. And then what I could do then is I could say, all right, here's some, put a note in there, how to run a GLM, period. If I use an asterisk and then write a command and then period, that's like just like a note. But then now I have this saved, and in the future, if I'm running this same analysis right here, right, running the same analysis, I can just like change the variable names and stuff like that. It would make it a lot easier for me. Again, because all I need to know is the variable name. I don't have to use this drop down tab to look for stuff, right? That's in the GLM. I have to look for variables. And it's a lot of extra work when, like, especially if you're in a crunch, you want to be able to just throw the name in there. And the SPSS even helps you. Look, watch this. SU. Since I had the data set open, it's already there. I just click it. All right. So anyway, that's a intro in how to run a GLM. Ask your instructor to help you if you have any other questions. Thank you. Bye.